Alright, so let's look at the first question. Find the equation for the line tangent to the curve x equals to t cubed plus 3y equals t4 at t equals -1. Also find the second derivative. Okay, so that's the problem. So at t, let's see the solution. At t equals -1, x equals 2 times -1 plus 3, which is 1. Y is -1 to the power 4, which is also 1. So you can see that the point is 1 here. And so the dy dx related to the parametric equation is dy dt, right, over dx dt. That gives us it's 4t cubed, right, over 6t squared. Turns out we have 2t over 3. Okay, 2t over 3. So evaluate at t equals -1. So the slope will be 2 times -1 over 3, -2 thirds. Okay. So the equation for the tangent, so it's y, because of point, coordinates are 1, comma 1, right? So it's y minus 1 equals -2 thirds, x minus 1. Okay, we're using the point slope form. So for the second derivative, it's dy prime dt over dx dt, right? So basically, you taking the derivative of this part, it can give it 2 thirds, and then over dx dt, which is 6t squared. So it turns out what you have here is 1 over 9 t squared, right? So if you plot the at t equals -1, so you're gonna have it's 1/9. Okay, so that's the first problem we want to talk about. The second one is gonna be, so find the length of curve defined, right? Parametrically by sine t, where between 0 and pi. So you can see for the second problem, if we take a look at this parametric equations, x equals cosine t, y equals sine of t, and noticing that, oh, excuse me, so this should be 6 sine t, okay. So noticing that if we do something, so you can see x squared plus y squared is going to give you 6 squared, right? So basically, this is a circle with the radius is 6. So if you're looking for the length of the curve, which is the actually the length of this curve is 2 pi r, right? And then so half of this circle is going to be pi r, which is pi times 6. So it's a 6 pi. So we can think about it into that way, or we can write it into the former definition about find the length of the curve parametrically, that is from 0 to pi square root of dx dt square, right, plus dy dt square, and then dt. So it turns out, this part is going to be negative 6 sine t squared plus 6 cosine t squared, and then dt. Right. So you can, this is like based on the property of the trig identity. So it turns out in under this square root is 6 squared. So 6 squared and a square root give you 6. So basically you have, and we know that the evaluation of this one is equal to 6 pi. Okay, that's pretty straightforward. Look at a couple of other examples. Keep going. So the next question I want to ask is to replace the polar equations, r squared plus 2r squared sine theta cosine theta equals 1 into, actually when we talk about replace this, basically we're asking replace this one into the rectangular, right, coordinates, right, because this is a polar. So talking about that part, there is so those are the guiding relationship between the polar and the rectangular coordinates. So what I like to do, like every time when I teach this subject, so I'll just so if I write this in terms of a polar, and meanwhile in terms of a rectangular, you will see that this length is going to be the r, this is going to be theta, right? So apparently you will see that the x coordinate here is going to be r times cosine theta, and then the y coordinate here is going to be r times sine theta, and based on those two we derive 3, right? And then if you take the ratio y over x, that's exactly tan theta. So yeah, either you can remember this or you can remember this both ways. So if we want to replace this one into rectangular, so you can see that we're going to have x squared plus y squared, right? Replace this part. And then for here, as you can see, we have a 2 times r squared times sine theta times 2 cosine theta. Basically, we can treat this part as 2 times r cosine theta times r sine theta, right, equals 1. So that gives us actually is 2xy equals 1. This problem is very straightforward. That's this one. And so number 4, so find area of a region in xy plane enclosed, by the cardioid r equals 2 plus 2 cosine of theta. So to handle this part of the area and the region here, so there is actually a formula So the area is from alpha to beta, right? R squared d theta here. So that's the area formula here. So and the problem you can think about it is we want to the area of this cardioid. So the theta is going to be from 0 to up pi. Okay. So following those two, so we can set up our interval. You see that? Okay. So basically, it's just evaluate this this interval here, and you'll see. So it's gonna be 4, right, plus 8 cosine theta, right, plus 4 cosine square theta, and then d theta here. And turns out it's becoming to 2 plus 4 cosine theta plus 2 cosine square theta and d theta. So this part to evaluate the first two is very straightforward. But to evaluate the integration of cosine square, so noticing that you're gonna need to use one of the trig identities, which is given here. So as you can see, 2 cosine square is equal to cosine 2 theta plus 1. So that's cosine 2 theta plus 1, and then d theta. Okay. And then you can see you're going to have 3 theta plus 4 sine theta, and then plus 1 over 2 sine of 2 theta, and then it's evaluated from 0 to pi. Okay. And noticing that, guys, basically you'll see that sine 0 and sine 2 pi is all 0. Same deal for sine 0 and sine 4 pi. So this part is going to be all 0. So basically what you're going to have here is just a 6 pi. Okay, so that's number 4.